Hello and welcome to another
NGen Math 7
lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing
Unit 7cc, Lesson 2
on populations and samples. Now remember, our entire Unit 11 is on the branch of math called statistics. And statistics is all about answering questions that have variability in them, okay? Now, when we ask a question, right, there is all the people or all the subjects it applies to, and that's called the population. So we're going to begin with thinking about that a little bit. All right, whenever we ask a statistical question, the group of subjects that the question applies to is known as the population. All right, so if I asked the question, how much money do lawyers make? You know, that's a great statistical question. There's a lot of variability in the amount of money lawyers make, but literally the population would be every single lawyer. Every lawyer! Maybe just all the lawyers in the United States, or maybe it would be all lawyers all across the world. But it would be all lawyers, right? That would be the population. So let's jump into exercise 1 and consider maybe one that's a little closer to home. Connor sends 28 texts in a week, and his parents believe that's a lot compared to other students in his 7th grade class. Connor decides he wants to answer the following question. How many texts do 7th graders in my school send each week? All right, great. So that's definitely a statistical question, right? Because there's going to be variation in the data. But what would be the population for this statistical question? That's pretty simple, right? It is every 7th grader in Connor's school. Every 7th grader in Connor's school. Every 7th grader . Now, it's not every 7th grader everywhere, right? Because Connor is just trying to answer the question, how many texts do 7th graders in my school send each week? Right? That's it. Now, Connor ends up asking all 120 of the 7th graders how many texts they sent per week. He then plotted the results in a histogram. You've seen histograms before. Sometimes they're known as bar charts. Answer the following questions based on this graph. Letter B. What category in this distribution did Connor's 28 texts fall in? How many students fell in this category? All right, so a bar chart always arranges the data in categories. For instance, on this one, and let's go to the screen real quick, right? The first category goes 0 to 4 texts. The next category goes 5 to 9. The one after that, 10 to 14 texts, 15 to 19 texts, etc. The height of the bar literally tells us how many students or how many of our subjects fell into that category. All right, so what I'd like you to do is pause the video now and figure out which of the categories Connor's 28 texts fell in and how many students fell in this category. All right, well, for Connor, his 28 texts fell in the category 25 to 29, meaning every single student that sent 25, 26, 27, 28, or 29 texts, right, they fell into this category. Now, how many of them actually fell into this category? That's where I'm going to look up here at the top of the bar, and I have to be kind of careful as I go over, but as long as I can read the chart off pretty accurately, I will find that 12 students fell into that category. 12 students. All right, letter C. Which category had the greatest number of students in it? How many students? This is known as the frequency of the category. So which category was the most common, right? We know that 12 students sent, roughly the same amount of texts that Connor did. We don't know for certain, but 12 students sent 25 to 29 texts. Right? Which of the categories had the largest number of students in it, and how many students were in that category? Pause the video now. All right, well, for this one, it's simply the tallest bar, right? It's this one. Now, if I trace down, what I'll find is for that tallest bar, the answer was 35 to 39 texts. And how many people actually sent that? That would be 19 students. 19 students fell into that top category. Now again, just a little terminology here, right? The number of the data values that fall into the category is known as the frequency of the category. So the frequency of the top category here, 35 to 39 texts, was 19. All right, now finally, letter D. Remember, ultimately speaking, Connor's parents think he sent a lot of texts, right? So letter D said, did Connor send a lot of texts compared with other 7th grade students at his school? Justify your answer. All right, definitely a statistical question, right? Because there's variability in this data. So what would be your answer? Did Connor send a lot of texts compared to other 7th grade students in his school? Pause the video now and write something down. Well, by saying does he spend a lot compared with other students would kind of imply that most students send less texts than him. And yet, his category, the one he fell in, is right here. The greatest category is right here, and there's a lot of people out here, right? There's a ton of people, right? If you think about it, everybody to the right here, all of these categories and all the people that fall in them sent more texts than Connor. So my personal take on this, would be to get on the right board. My personal take on this would be no, because more students sent more texts than Connor than less texts. Now, of course, I didn't add them all up to really prove this seriously. We'd have to kind of come in here and we'd have to take every category that had more text than Connor's, figure out the frequency of each one of those intervals and add them all up to be able to say, okay, you know, out of the 120 students, 80 of them sent more than Connor. But it's pretty obvious, given that this is Connor's category right here, that there's a lot more that sent more text than him than less text. The ones that sent less would just be the ones in here. All right, so let's kind of keep working with this particular exercise. Now, sometimes recording data from every subject in a population is either impractical or literally impossible. In those cases, what we try to do is we try to just get a sample of the population, all right? We just try to get a sample, right? And then we try to say something using the sample about the population. So let's take a look at exercise number 2. Connor's parents claims he sends a lot of text compared to a typical 7th grader. They want to answer the question, how many texts does this typical 7th grader send per week? Why isn't it realistic to get a measurement, a response, from every subject in this question's population? Why don't you pause the video now, see if you can answer that question. Well, it's pretty much this simple. Since we're talking about the typical 7th grader, then the subjects that are in this population are every 7th grader. Every 7th grader. Maybe even, given how open-ended the question is, every 7th grader in the entire world. But even if we just limited it to the United States, I mean, even if we just limited it to the state of New York, where I teach out of, you know, it would still be too many. There are simply too many 7th graders. Too many. Too many 7th graders to get a response from all of them. The vast majority of times when we take data to answer a statistical question, we take a sample of a population. just a sample of it. And then we look at that sample and we try to say, well, you know, this sample tells us the following about the population, all right? And that would definitely be the case here. We would never be able to get all the 7th graders. So if Connor's parents really wanted to answer this question, what they'd want to do is get a sample of 7th graders, but they'd want that sample to be representative. So it is very important that when we use a sample of a population, that it represents the population and isn't what's called biased. And you've probably heard of the word bias, you know. You've probably heard that in your life at this time, right? When we talk about a sample being biased, it means that if you took the sample, then the sample wouldn't really represent the population. There'd be something about it that maybe would mislead us about the statistical question that we're trying to answer. So representative samples versus biased samples. A sample is called representative of a population if you can draw accurate conclusions about the population from the sample. A sample is called biased if it leads you to incorrect conclusions about the population based on the sample. All right? That's amazingly, amazingly important. A lot of times when people come up with incorrect conclusions based on statistics, it's because their sample wasn't representative of the population as a whole. And statisticians, those are just professional people that do statistics, statisticians work hard to try to make sure that their samples truly represent the populations. So let's take a look at that idea in our last exercise, exercise number 3. In each case below, describe whether the sample taken of the population would be representative or biased. Explain. Letter A. Isabella is trying to answer the question, how many social media sites do kids in my school use? She takes a sample by asking 15 of her closest friends. All right, so maybe Isabella goes to some very, very large school, maybe in New York City, let's say, right? Assuming that her school hasn't been canceled for a little while, right? So let's say she's at a huge school in New York City and she wants to answer how many social media sites do kids at my school use, right? So, you know, she doesn't want to ask every single student there because maybe there's 4,000 kids. So she takes a sample of her 15 closest friends. Would that be representative of the population, do you think? Or do you think it would be biased? Pause the video now and write down one of those two, and then maybe write down why you think that's the correct choice. All right, well, it's likely going to be biased. All right, and let's talk about why that is. All right. When we do a sample of a population, we want it to be as random as possible. Random meaning that, like, I'm literally closing my eyes and I'm just grabbing test subjects, right? I can't see them. I don't want them to be in any kind of particular order. I don't want them to come from any particular group. I want them to represent the population as a whole. So this one is biased, and it's because the sample is not random. Random, not random. That's not even a word. Not random. She only used her friends. Now, side note, if her statistical question was, how many social media sites do my friends use? Then asking 15 of her closest friends probably would be a good idea. But then she might be able to get the population, right? But if she's talking about just kids at her school, this is biased because the sample is not random. She didn't randomly choose people to ask. She found her 15 closest friends because, let's face the facts, those would be easy people to ask. And she asked them. But it could be that her friends, on the whole, use social media websites more than people at her school in general. Or maybe they use them less. But since it's not randomly selected, it's going to be a biased sample. Let's take a look at letter B. Jackson is trying to answer the question, how often do students in 6th grade buy lunch at school instead of bring it from home? He takes a sample of students by asking every 5th student who walks into the cafeteria how often they buy lunch per week. All right, so what do you think? Biased or representative, and why? Pause the video now. All right, well this time it's going to be representative in all likelihood. Okay, and it's going to be representative because Jackson used a random sampling, let me call it method. All right. So picking every fifth student is a very good kind of random sampling method, you know, and you'd want to be wary about like something if Jackson simply asked the first 20 people who walked into the lunchroom, that might be a problem. Because maybe the people who get to the lunchroom first are the ones who, you know, really want to get in line for the hot lunch, right? The lunch that they serve, and maybe people who bring their lunch kind of mosey and get to the lunchroom a little bit later. So you wouldn't want to do that. But by basically saying, okay, the first person that came in, great. And what, every fifth person? So the sixth person that came in, grab them. Then maybe the 11th person that came in, grab them, right? So now what's happening is that Jackson is using this kind of random methodology of just, hey, every fifth person I'm going to ask, are you buying your lunch or did you bring your lunch? And therefore, in likelihood, Jackson is going to get a nice representative sample, and whatever he concludes based on that sample is likely going to be true about the population. Let's take a look at one more. Letter C. Mila is trying to answer the question, how many pull-ups can a typical 8th grader do? She asks 10 8th grade girls who are on her gymnastics team as a sample. Great. All right. So what do you guys think? Did Mila get a representative sample or a biased sample here? Pause the video and see what your answer is. And again, this is a very, very good example of a biased sample. Again, it's all about randomness. Mila did not ask a random sample of people. Those on her gymnastics team will likely be able to do more pull-ups than normal, right? So if Mila is trying to answer this question, you know, how many pull-ups can a typical 8th grade student do, right? And again, there are some people that can't do 0 pull-ups. There are some that maybe be able to do 20. I can't imagine doing 20 pull-ups, but I'm sure there are some. But if all she does is ask the girls who are on her gymnastics team, right? Gymnasts generally have good upper body strength, right? They can do a lot of pull-ups. I think they even train doing pull-ups. This is going to be a terrible sample because she might find that the average number of pull-ups that people can do in her sample are like 12. So if she then concludes, well, a typical 8th grader can do 12 pull-ups, that could be completely off base. It could be more like 4 or 5, right? But because she has a biased sample, because she didn't just ask random people, and quite frankly, she should go back and talk to Jackson. She should ask every 5th person that walks into the cafeteria, you know, how many pull-ups can you do? Here's a bar, go ahead and try. You know, then she's going to get a nice random sample. But the way that she's done it here, her sample is going to be biased, and it's going to lead her to the incorrect answer to her statistical question. And you never want to have that happen. You know, a lot of times when you look at polls of like elections, and I'm sure during election season, you might see something where, you know, candidate A and candidate B, and here's a poll and who's leading and things like that. The problem with the polls like that is that they're always a sample of a much larger population. I mean, like talk about like a presidential election where you might have 130 million people who are voting, and maybe somebody goes out and asks 1,000 people who they're going to vote for. Well, you want those 1,000 people to represent the population as a whole. But if you don't ask them in a random enough way, if that sample doesn't represent the population, then you might think, oh, these results tell me candidate A is going to win, when in fact, on election day, it turns out to be candidate B because the sample didn't represent the population. All right, well, we'll talk more about samples and populations as we move on throughout this unit on statistics. For now, I just want to thank you for joining me for another
NGen Math 7
lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.